Question number 30. Two loads are connected to AC supply mains as depicted in the figure. One load draws 10 kilowatts, whereas the other load of 10 kilovolt ampere is operated at 0.6 power factor lagging. To achieve an overall power factor of 0.9544 lagging, the nearest kVAR rating of the capacitor bank needed to be connected across the supply mains is equal to. Okay, so essentially we have a AC supply. There are two loads. Okay, let me explain what this is in a moment, but we want to add another capacitor to this so that we end up with the overall power factor of this being 0.9544. AC circuits, the voltage is not in phase with the current, right? So just the product of voltage and current, that's known as the apparent power. Okay, but if you look at the component that's where the voltage and current are in phase, VI cos phi, right? That's called the active or real or true power. Okay, and the component that's not in phase, where the voltage and current is not in phase, that's called the reactive power. Units for this is volt ampere, watts, and volt ampere reactive. Okay, and the power factor here is essentially the ratio of true power by apparent power. That's a power factor. Okay, so for given any loads, it's a good idea to just draw the power triangle. The nice thing is you can add and subtract sides because they satisfy complex arithmetic. Okay, for example, so let me explain what I mean by that. So 10 kilowatts. So the power triangle corresponding to this load 1, is just a single line because all of it is active power. There is no reactive component. Okay, that's also equal to the apparent power. So this is a triangle with zero height. This thing. So 10 kilovolt ampere is the apparent power. Okay, power factor lagging. Lagging means this triangle is facing upward. Leading means triangle is facing downward. So power factor is 0.6. So ratio of this by this is 0.6. So this is 6. Okay. So this is 6. This is 6. This is a right triangle. So this should be 8. Okay. Now they satisfy. You can add and subtract size, base and height. So if you add these two, the net triangle for this is 10 plus 6, which is 16. That's the base of this. The height of this is 8. So this is where we are currently, the black triangle. We want to end up at a red triangle whose power factor is 0.95. Okay, so 16 divided by 0.95. Okay, that should be the length of this. That's the definition of power factor. So that turns out to be 16.76. Corresponding to that, the height over here is 5 kVAR. Okay, if 8 has to become 5, we need to add a capacitor that has a leading downward triangle. This is a triangle with just no base, just the height. Okay, we need to add a triangle of, we need to bring it down by 3 kVAR. So this is the effect of the capacitor. There is no active true power in a capacitor, just all of it is reactive power. The value we want is 3 because that will bring 8 down to 5. So the answer here is option A, which is 3.